Hey there, space explorers! Ever wondered what it would be like to step into a four-dimensional world? Or why some scientists talk about multiple dimensions? Today, we're embarking on a mind-bending journey through the concept of dimensions. Buckle up, we're about to stretch your perception of reality. What is a dimension? At its core, a dimension is a way to describe the minimum number of coordinates needed to specify any point within a space or an object. Let's break it down with some examples. 0D, a point. No coordinates needed. It just is. 1D, a line. One coordinate, length, tells you where you are. 2D, a plane. Two coordinates, length and width, pinpoint your location. 3D, our physical world. Three coordinates, length, width, and height. Nail it down. But hold on to your hats, because it doesn't stop there. In physics and mathematics, we often deal with higher dimensions. For instance, in 4 dimensions, we add time to our 3-dimensional world. This is how Einstein described spacetime. In string theory, physicists work with up to 11 dimensions to describe the universe. These higher dimensions aren't spatial like we're used to, but they help explain complex phenomena in our universe. Topological dimension in Euclidean geometry. Now, let's zoom in on how we think about dimensions in Euclidean geometry. The geometry of flat planes and straight lines that you probably learned in school. In Euclidean geometry, we use something called topological dimension. It's all about how we move through space and the degrees of freedom we have. Imagine you're a tiny ant. On a line, which is one-dimensional, you can only move back and forth. 1 degree of freedom. On a plane, which is two-dimensional, you can go left, right, and forward, backward. 2 degrees of freedom. In 3-dimensional space, you can also move up and down. 3 degrees of freedom. Each new freedom of movement adds a dimension. Here's where it gets interesting. Consider these examples. A piece of paper. Normally, we think of it as 2-dimensional. It has length and width, but negligible thickness. But when you crumple it up, it occupies 3-dimensional space. Topologically, though, it's still 2-dimensional. The surface itself hasn't gained thickness. A wire. We often think of it as 1-dimensional when drawing circuits, but in reality, it's a 3-dimensional object, just very thin in 2 dimensions. The surface of a sphere. It exists in 3-dimensional space, but topologically, it's 2-dimensional. You only need 2 coordinates, like latitude and longitude, to specify any point on its surface. These examples show how topological dimension helps us understand the intrinsic properties of objects, regardless of how they're bent or positioned in space. So there you have it. Dimensions aren't just about the 3-dimensional world we see. They're a powerful tool for understanding the structure and complexity of our universe, from the pages of your math textbook to the far reaches of theoretical physics. Next time you're navigating with GPS, remember, you're not just moving through 3-dimensional space, but through a 4-dimensional space-time continuum. Keep exploring, dimension travelers, and never stop questioning the nature of our reality.